So we start now. Good morning once again to Solutions Plus training program. This is a 1 week training program which is tailored to stakeholders in the e-mobility sector. And this week we are tackling the issue of charging infrastructure. So yesterday we started throwing an overview on the e-mobility sector in Africa, taking stock of where we are now. And today we are going into charging infrastructure. It might be a bit technical, but we believe that this is very necessary also considering the ecosystem that we have. So we will be starting very soon with our presentations. Just a quick recap on the Solutions Plus project for those of us who were not in the program yesterday. The Solutions Plus project is an EU-funded project which is intending to transform the urban electric mobility sector in Africa, not only in Africa, but also in other emerging economies. So we are indeed in Latin America, also in Asia, and then we are drawing, of course, also experience from the EU industry, where we have several partners with expertise in various sectors of the e-mobility sector who are helping us to deploy electric mobility solutions in these countries. The Solutions Plus project intends to support the sector with vehicles, talking about assembly, talking about remodeling, and also deploying associated business models. We also intend to support our local innovators with innovative charging solutions and also integration, where we intend to integrate these solutions into policy and also financing, and equally deploying very innovative technologies to integrate the sector with the public transports. So what are we doing? We are deploying a range of tools, methods, and guides. And then we are also encouraging training, just as we are doing now. We are building partnerships between European and then local innovators in these demonstration cities. And we are doing on-ground demonstration activities where we are supporting local innovators with direct financial support and as well as equipment. Whilst we do this, we intend to sustain the measures where we are engaging local authorities, national authorities to integrate innovative e-mobility solutions into policy. So what are we doing today? We are just taking one of the issues I've discussed here, or one of the measures we are deploying via training, via capacity building, and we are having regional trainings. We will also be having city-specific trainings in our demonstration cities, particularly in Dar es Salaam and also in Kigali. And this is coming up also in October. We indeed invite you to these trainings as well. So yesterday, as I said earlier, we took stock of what's happening in Africa, particularly in East Africa. And then today we are zooming into charging infrastructure. Now, just to give you an overview of what's happening, and then I want to give you an illustration of this. If you remember, about a decade ago, you have several charging solutions for mobile phones. And I believe at the point, some of us here had a pile of charging equipment, charging solutions for our mobile phones. Over the decade, there are a lot of talk to harmonize charging solutions for our mobile phones. And then today, we can all bear witness that we don't have so many of solutions. We have the Android solutions, we have the solutions for Apple, but not as many as before. And just this recent time, just last week, the EU is already proposing to have a common charger for electric devices. So how do we reflect on this also for the e-mobility sector, where we need perhaps at this time to start talking about how to harmonize our charging solutions? Do we need to have a common charger? Do we need to talk about interoperability? So today we have our experts to throw some perspective over this for us. We will start with EV charging solutions overview, talking about interoperability and benefits. And then we have two case studies and also question and answer sessions in between. So you're welcome again to today's session. And then we believe this session is going to be very, very interactive. And we will also open the question and answer session where we take your questions and then have our experts give us answers to this. So without much ado, I will give the floor to our first presenter from IDIADA, Solutions Plus partner IDIADA. So Guillaume is from IDIADA. He's giving us the first presentation on electric vehicle charging solutions overview. Guillaume, over to you. I will stop sharing and then you take it over.
Thank you. Thanks, Edmund. You should very soon be able to see my screen. You appear to be on mute, but I think it should be working. So as said, I'll start the session with this presentation on EV charging infrastructure. It will consist on different parts. I will be tackling the easy part probably, which is just a good technical reminder on why we as a society are pushing on electrification for transport and different types of transport. Then very fast recap on the landscape, how it is evolving and how it is shaping our cities around the world, and also a short overview on what is working today for charging our vehicles. And then the later part will be focused on charging interoperability. That will be also divided in two parts. FEAR, Edwin from FEAR is supporting us with the interoperability concerning from the user to the charger, so more the user experience. And then my colleagues from IDIADA will provide a deep overview on what it means for the vehicle and the charger to actually charge, what's going behind, what needs to be taken into account, and how to make it work smoothly. So you will see that there are different types of information. We've tried to make it quite understandable, but we are aware that some of the parts will probably appeal to a certain part of the audience. I hope it's not too boring if that's the case, but I'm sure it will at least be interesting to all of you. To my colleagues, I would like to call them, as I always do, for help if they want to break in at any point. Just feel free, as we tend to do. So on the overview set, we like to provide this short introduction to why electric vehicles. And there are different reasons. We are seeing that for the urban use case, the electric vehicle is especially suitable, as it does mitigate some of the drawbacks due to the technical characteristics it has. So when looking at how efficient a electric motor is, we see that when compared to an internal combustion, it's of course way more efficient, but probably the most important part is that it stays in a very narrow margin of efficiency difference. So it is always very efficient. So an internal combustion engine would range from 20 to 40 according to the use case. But then electric vehicles stay way above 90% efficiency most of the time. That means that in the cities in which we are stopping and then retaking our journey for a lot of times, it's definitely an advantage. Also, pushing light electric vehicles introduction is the fact that light electric vehicles do not need long range, but do need a lot of charging points, and that's the case in urban environments. Um, Also, we're seeing that light electric vehicles, and this is meant to change very soon, don't have a very high regulation pressure that makes it easy for manufacturers to launch vehicles in the market. That's meant to change, but that's the situation today. Also, we've seen that in the last 10 years, prices of the most expensive component in the vehicle are dropping significantly. And also in favor of the urban use case, we see that, as said, the journeys tend to be short. So it is possible to carry small batteries and not having to plan. So that's on one side of the spectrum we'd like to start from, that pushes electric vehicles introduction into our urban environments. But then on the other side, we also see that it's very beneficial as well, not only for the convenience of the light electric vehicles, but because of the numbers behind the operation of those vehicles. So we've made some comparisons on total cost of ownership. There are plenty. We've made our own. The conclusions tend to be the same. For the urban environment, it is very easy that an electric vehicle can provide a better economic efficiency than the internal combustion engine counterpart. It is then important to note that the way the vehicle is used is very important on defining the costs. Because depending on the charging infrastructure, and then my colleagues will dig deeper into it, we can extend or reduce the battery lifetime. And that is affecting significantly the capex, the upfront investment for the vehicle. So a proper charging model, therefore a proper charging infrastructure, is key to make the battery last longer, and that's actually one of the decisive points that can make one or other vehicle to be more suitable, also in terms of economics for urban environments. Yes, could extend more here, but I think the message is already clear. Then things we're glimpsing from Ideal as an engineering service provider, according to the requests that our customers come to us with. One of the greatest concerns is to right-size but future-proof charging infrastructure. It's important when planning a new or a renewal of a urban charging infrastructure to take into account the current needs, but also the future needs, to plan ahead and make the transport, so the road transport charging electrification maybe work alongside with the metro, should there be one, or to integrate it in a way that it's not very disruptive, but with urban planning. So it should not be taken only looked at solving a very short in time transport need. So it's quite important. We're also helping in that. The image you can see on the lower left corner is from a project exactly devoted to this, to help cities plan ahead. And then we're also quite aware that choosing the right vehicle for a very specific use case is something that typically cities tend to struggle with because they just didn't have to cope with very technical details from the vehicles. Internal combustion engine, it's not the case now. It's totally worth it to really understand what a specific use case for a specific city means in terms of technical requirements from the vehicle and the infrastructure to make it work. Firstly, in a safe mode, but also in a reliable mode in time. As per current landscape, here I don't think anyone will be surprised, but we wanted to share a very fast glimpse on the evolution of the battery-powered vehicle. Here, that's an overview of every alternative fuel registered in Europe. So it's Europe only, but I think it's a good overview. What we can very clearly see is that battery-powered vehicles, so the ones in the lower columns in yellow, are following what we could identify as an exponential curve, and that's not meant to change. So we need to just accept that it's the kind of vehicle we need to plan for. And that's affecting both passenger cars, what we all do understand, but also light electric vehicles, especially, of course, in urban environments for reasons we've explained before, and also heavy duty vehicles, so bus and road transport, in-city road transport. Those are important, and we'll go to it in the next slides because they are the ones that have more specific and infrastructure-intensive requirements in terms of charging. So it's those are maybe the ones that should be taken more into account in planning. For this specific reason, depending on the vehicle, the voltage is different, and therefore the charging does have some different requirements. Light electric vehicles, typically ranging from 48 to 126 volts, do have lower requirements in terms of power and safety. It's not the case for passenger cars, but what we're spotting in the market is that even passenger cars are switching to medium voltage, what we could call anything below 450, to high voltage and approaching commercial vehicles. We've written here 650 to 800, but the introduction of 1000, so 1000 volts is also coming, and that's as well affecting how urban infrastructure should be planned. Very quick, as Edmund was explaining in the beginning, there's plenty of different regulations, and they do not apply everywhere the same. So that's a map with the distribution of the countries in which one kind of charging protocol and therefore charger is the typical one. We're seeing a very clear trend in North America to go for CCS1. You'll see the chargers themselves in the next slides. And then the rest of the world is quite, except for China and Japan, who have their own, it's quite commonly adopted, the CCS2, which is a PLC-based charging protocol. So that's the map, and that's the chargers that go alongside to it. As we were saying, US is the combo one, and then combo 2 is the one applying in Europe. Those are PLC-based communication protocols rather than CAN. CAN tend to be the ones used for Japan and China. That's the chargers we see today in the street. But then again, charging with those cables is one of the ways in which charging is performed, but not the only one. What we've tried to share in this image is a top right corner. We've tried to show different types of inductive charging, which is already coming to our cities. And then the lower pictures are trying to depict pantograph charging, which is the most common way to charge buses during the journey, so opportunity charge. That's very infrastructure intensive, but it has shown it's the correct way to charge those vehicles alongside with slow charging for reasons we'll go deeper into in the next slides. So that was the overview for today, but then we also need to take into account what's coming in the next years. We've talked about pantographs for buses. Now we are already investigating catenaries, which allow for dynamic charging, which means that the bus can charge while moving. And then, as we said, there's this trend of raising charging voltage, therefore power in passenger cars, but not only. And we're seeing plans to go up to 3 kilowatts. I'm sorry, 3,000 for the next years for charging, which is yes, it's very high. Let's put it this way. It's not only because of the voltage itself, it's because of the infrastructure needed and the measures needed to make it safe. Because of this kind of power, human operation is no longer recommended. We'll put it this way. So that's a little bit the overview on how vehicles should charge, different technologies, what's coming, and how it's going to be distributed around the world. And now I will leave the floor to my colleagues from FEAR and from IDIADA to provide a deep understanding on what interoperability is, which is the key and probably the hot topic in charging, and how it both applies and why is it necessary for the user and the infrastructure itself. So yes, please, you're free to jump in. I'll be sharing the slides as required.
Yes, good morning. Hi. Thanks, Guillaume. Thank you for the good presentation. And I will dive a little bit more deep in the charging interoperability. My name is Edwin Westerneurtje. I'm from FEAR Automotive. We are also partner within the Solutions Plus consortium. And at the moment, we are looking at charging infrastructure interoperability. And on Thursday, we will also dive a little bit more deep. Yeah, maybe you can come back to the first one, Guillaume, the user-centric.
Sorry for that.
Yes, it's okay. I think one back.
This one?
Okay. Yeah, this one. Yes, thank you. Yeah, I will explain on Thursday a little bit more on the localization, which is also important, and it's also in this presentation later on. Yeah, if you look at the whole structure of charging, it looks very difficult, and it looks like a lot of companies and organizations are involved, and you need a lot of protocols. You see on this slide, of course, the important protocols. And I think in Europe, it's more and more common now. We want to have, for the user side, that protocols are easy to use and open. And of course, you have protocols between the energy market and you have protocols between the operator and its backbones. But the most important protocol is, of course, the one between the user and its charge point, because that is the connection that always needs to be done. And that always needs to be very easy to be done. Because I'm not a technical guy, I'm only a user of an EV. And I think 90% of my colleagues who drive an electric car or an electric scooter or a bus or a truck in the future, they will also not be technical people. So if you go to a charging point, you want to plug your car and you want to be easy charging. And you see that you want to have that hassle-free, and also what it is that you know what you pay for that session. That's an important protocol, and we are looking at technical protocols in that. But for the user, it is not technical at all. So it is, okay, I have my plug, I have the right plug. For example, in Europe, the CCS2, like Guillaume explained, it needs to fit in the charging station, or it needs to fit from the charging station into my car. And then I want to have it starting the session. And in many cases, you have a charge card to activate your charge point, and it needs to be starting to charge. And sometimes you have an app, or you have a screen on your charging station where you can see what the price is for that charging per kilowatt hour, or maybe sometimes per minute. But you need to know at that moment, what do I have to pay for that charging session? And all the things around it, like the charge point operator, the e-mobility service provider, and the e-roaming platform, they have to cooperate to make it as easy as possible for me as a user to charge, because I'm the client for all of them. And also from the energy generation and the energy market, things more and more important in electric mobility is, of course, that I want to have clean electricity in my car or in my vehicle. So also from that side, they have to cooperate and give me more and more the knowledge and also the openness that I have green energy, green electricity in my car. Yes, please, Guillaume, next slide. Yes, so for me, it is very important that it's open and transparent. What I already said, it's enabling the acceptance of EVs, it's reduced the risk assets, and enabling access to all users. So I want to have access to all the charging points, and I want to charge wherever I want. And also on performance and cost, I want to meet my expectations. So when I expect a session to be, for example, 10 euros, and I'm charging my car, and after the session, I'm getting an invoice, and it's not 10 euros at all, but I also have to pay, for example, per minute. So not only on the kilowatt hours, but also per minute. And my invoice is much higher than I expected at the moment that I charge my car. So it's openness and it's about user satisfaction. And the industry who creates that needs to make it as easy and also open for me as possible. So also the risk for, of course, the risk for that the connection, that the technical connection is always okay, that also needs to be reduced. So failure of the charging point needs to be a little bit lower than 100%, but it needs to be much more above 90%. Yes, please, next slide. This is a very important slide, and this is what we think would be KPIs for all electric mobility users, and therefore also for the CPOs and all the market who is providing charging infrastructure. This is a little bit focused on DC charging, but in total, if you go to charge your car or your vehicle, these 4 very main points needs to be done. So on the left above, you need ensure sufficient coverage. So in Europe, for example, we have a lot of KPIs on public recharging points, so that all users know where the public charging points are. And it is based on the EVs which are registered. Guillaume showed you the statistics of of Europe with electric cars. And based on that, you need also to have enough public charging points in the future and now. And you can also calculate it per capita or per square kilometer of land area, but at least you need to calculate how many EVs do I register in my country or in my region or in my continent in this case, and how many charge points do I need for that to be able to provide them enough chargers to drive along the region. And what I said, the metrics can be measured on national level, but it's even better to do it on a regional level. So if you have a city and a region around it, or maybe connected cities, please work together on these metrics. And if you have sufficient coverage, be open also to the EV user and show where the charge points, the open charge points are, because they have to find them. And it's sometimes not so easy to find it. Then the second one, seamless charging, I explained already a little bit about that. It's needed to ensure that not only in your own region it is seamless to charge, so that you have your charging card and you can click on the charger and it starts running, but also when you cross border or when you go outside your own region into another region. And that is called cross-border interoperability. So whatever card you have, wherever you are a member of with a membership card, it needs to be interoperable with other charging stations outside your own region. And if you cross borders, Sometimes, and in Europe it is still a lot of times the case, also have roaming. And roaming, a lot of people know the word also from the phones that we have. In the beginning, roaming was very expensive. And that is also a little bit the case in some regions. If you go in Europe and you have to activate a charging station outside your own country, also pay roaming costs for that. And that is now what we are also lobbying on within Europe, that roaming activation of a charge point in another country is as low as possible, because it's sort of extra cost that you don't expect. And within seamless charging, you know roaming is important, but keep it as easy and also as cheap as possible. And of course, appropriate assistance. When you have 24/7 charging stations available, you also need assistance 24/7. Also at night, you need to have a telephone number or an online where you can have your questions on. And if a charging station is not activating, you need immediate assistance. So a CPO, together with the system around it, needs to focus also on customers who want to charge and come very late in the evening to a charging stations, 11, 12 o'clock in the evening. If it doesn't operate, you need to have direct assistance to them. The payment, of course, I explained, it needs to be transparent at the moment that you are going to charge. And it needs to be able to also pay without a contract. Because it's not always the case that the user has a contract with somebody. He just has a bank card and wants to pay with that bank card. You need to have that possible for the user. So if you are only possible as a member to charge, it's not open. It's also when you come abroad and you want to charge immediately. Not want to become a member or of a local service provider or something like that. So always need also to be able to pay and charge contractless. And then last but not least, and of course it's a little bit not 100% within the part of interoperability, but standardization of facilities is also very important. At DC chargers, at fast chargers, you have to wait sometimes 20 minutes with some vehicles, sometimes 45 minutes. So you are then at the local station where you at least need lighting, that you can see what you do when you're there at night. And at minimum, you need to be safe, feeling safe there. And you also need to be, of course, with COVID, it's important more and more that it is clean and it's hygienic there. And if you also provide availability of food, drink, leisure services, then it is a station where you can also build up more and more a business case. Of course, this is more on the fast charging, because there you wait with your car or your vehicle whenever it is already fixed and charged. But also on other charging stations, it's important to have facilities around it. Yes, next slide, please. Yeah, you see, if you look at the whole system, and this is an example of Europe, the user is the one who has, for example, contact or is member of the e-mobility service provider. Examples in Europe is NewMotion, which is now also part of Shell Recharge, of the Shell Group. You have Has2Be, you have Virta. These are the member cards that you use when you charge your car. Behind that, a little bit step back, you have e-roaming platforms. Those are the ones who provide you with the apps and also the backbone of the charging stations. So they have the details of the charging station, for example, also what you pay per kilowatt hour. And you have the charging site host and the charge point operator. They are the ones who are the technical part behind the charging station. So the charge point operator, for example, is one who is operating the charge point itself and also provide all the information to the services. And together with the charging site host, they also provide the services like food or the toilets or other things around it. And then you have the producer, like ABB, which is in our consortium in Solutions Plus. They are the ones building up the charging stations. And of course, on the energy side, you have the energy suppliers who want to have more and more that they provide green energy. So you see here the whole structure, and that all has to communicate. And the final part of the communication, and the most important part, is the customer and the user itself. Yes, next, please. Yeah, and if you look at the whole situation, and in Europe we already have a long years of electric vehicles on the roads, and you see that in Europe this happened in the last couple of years. More and more charging member cards and more apps that you have on your phone, the apps to find the charging stations, to be able to start charging, and also with the member cards you are also be able to start charging and to pay. In this case, we need, for example, if you start in Africa building up systems and building up protocols, please avoid to have these many apps and these many charge cards, member cards. Please avoid fragmentation in the market. There are more and more standard protocols, so that, for example, you see here the Maingau charge card or another one. More and more in Europe, you can use one card to go through on the all of Europe. So also the apps and the cards are going to be more and more minimized. But it was in Europe in the beginning, and also still the situation. If you want to cross your region or cross the borders, you need a lot of charging cards in your car. And you need, I have, for example, at the moment 6 or 7 apps that I use regularly when I drive to Germany or I drive to Belgium, or last summer I was in Spain, I needed another app. So please, in Africa, try to avoid that part. Yes, I think was almost my last slide. Yes, this is, I think, a sort of conclusion. You need to have compatibility, not only the plugs that Guillaume explained, but also the protocols needs to be compatible. And the EV driver needs to be the easy one to have interoperability inside. Okay. I think this was my part.
That's correct. This is already for my colleagues. Thank you
Yes.
for your intervention.
Okay, Guillaume, I will request the remote control. Let's see if it works.
It should be now approved.
Okay. Nice.
Good morning, Santi and Jayat.
Yes, this is Santi from Idiada, and I've got Terari bars here. I will complement a little bit the explanation on interoperability, and I will start from a very nice slide presented by Edwin. On this one, on my part, I will focus on the interoperability between vehicle and charger. It is true that there are many protocols, and the first that the OEMs and the infrastructure producers have to overcome is these 2 basic protocols, and they are very complex, and there are many problems of understanding how they have to be applied. So for this reason, I will focus a little bit on this part and explain a little bit the interoperability between electric vehicle and infrastructure. Yeah. First of all, there are 2 main protocols for DC charging. This is focused on CCS, the maps that Guillaume mentioned. This will include the charging for Europe, America, Australia, and a big part of South America. There are two current protocols for M1 passenger vehicles. This is the DIN 70-121 and the ISO 15118. And for heavy duty applications, there is a version of the ISO 15118 from 2010 that has been modified for pantograph charging. Yes. So for the CCS plug that Guillaume also shown, there are many pins. Basically, the upper part is for AC charging, the lower part is for DC charging, and within the upper part, there's this important pin that includes it's called the control pilot, and it includes all the signaling necessary for operating a safe charge. Within this control pilot signaling, there is the high-level communication where a lot of information it is constantly being exchanged between the vehicle and the charger, and it has to follow these two protocols mentioned above. If any parameter is different than the regulation requires, the charge is stopped. And on the other hand, there is another type of communication overlap on the same high-level communication, that is the CP states. There are three states. There is a PWM signal where it starts at 12 volts, and once it is connected and a bit of communication is exchanged, there is the part where no power is transmitted, but at least some parameters are exchanged. This part is used to see the compatibility between the vehicle and the charger, and if they are not compatible, the charge is stopped. In this way, it is not necessary to let's say, energize the charger, and it can be stopped without having the capacitors charged and without having any type of risk. Okay. A very important part as well is the role that the EV has on the charging. The electric vehicle is the one that always commands the charge and always sends the first message, the request. During this high-level communication between vehicle and charger, there is always a first message sent by the vehicle, and then the charger has to answer. So there has to be a big work on the OEM side to have a good understanding of the charging protocols in order to request a good message. So very quickly, all the phases that while you are charging an electric vehicle, all the phases that are happening are the following ones. First, a connection where there is a signal level attenuation process that it allows you to identify if the vehicle is really connected to the charger. Then, once this is surpassed, there is the initialization, a service discovery, where you select what type of, let's say, service do you want to use with the charger. It can be charging your vehicle, it can be using internet, or another type of applications. The main one, of course, is to charge the vehicle. Once this is selected, you go to the charging phase. And here you can see all the phases that appear within this charging phase that are meant to validate that the charge is safe. A bit of detail on the previous part, the initialization part is the one where you select the protocols mentioned above. There are not that much protocols, but they are complex. So it takes a lot of time for the OEMs to really understand and implement correctly the protocols. So in this very beginning phase, you can say, I want to charge with one protocol. If the charger has it implemented, it says, okay, then you can go forward. If not, the charge is stopped. Sorry, I forgot another part. This is the authentication part at the service discovery phase that I mentioned before, where Edwin as well comment there are many types of cards used depending on the service provider. This is the part where you have to validate that you are a member and you can and yeah, you can charge. If you don't have this card, then the charges stop as well. And also this is a point where, especially for fleets, it takes quite a lot of issues. If the vehicle is not included in the database, sometimes the charge is stopped as well. And going very quickly to the charging phase, at this point, the charger is energized, and there is the safety check at the very beginning, where you check the isolation on the line. There is this isolation monitoring device and the regulation shown above, where some limits have to be achieved. If let's say the resistance is very low, there is a fault trigger that the charging is stopped. This avoids to have let's say a short circuit or some kind of earth fault, and this is detected at the very beginning of the charge to make it really safe. Once this is passed, there are another phase before charging itself the vehicle. Now the contactors of the vehicle are open still, but there is this very important phase as well, that is the pre-charge. Here there is this exchange of communications, and the vehicle tells the charger which is the battery voltage. Guillaume has mentioned at his slides that the voltage is increasing constantly, and this is an important part for this phase, because the charger has to be ready to increase the voltage to the battery of the vehicle. If this voltage is not increased in time, the charge is stopped as well. So finally, the current demand phase, now the vehicle can be charged, and is where all the users want to end up going, to the current demand phase. At this point is where really the vehicle is started to charge, and the SOC starts increasing. So here there are also interoperability issues that can be seen. Mainly the most important one can be the noise injection. This is why also a lot of interoperability or conformance testing has to be performed in order to identify this issue at the very beginning and try to solve it. Otherwise, the charge is quite probable to be stopped due to the loss of packets on the messages, as can be in the image below. The last part, but not the least important, is the finalization of the charge. It has to be according to the regulations as well, in order to preserve and let's say extend the life of the components. If the charge is not, let's say, it doesn't follow the regulations, we can see over voltages and damage of some components. So here, what is recommended is to reduce the current at the very end of the charge, always commanded by the vehicle, and allow a safe opening of the vehicle contactors. So as we have seen before, there are many possible parts where issues can be found. This is why it is really recommended to perform an early validation of the onboard charger. That is the ECU that has the charging protocols implemented. And here at IDIADA, we have all the tools and simulators to validate this component. The next step, once the component is validated, is to include this component within the vehicle, and then check interoperability by selecting one solution and attempt with different chargers. Here you can see many charger manufacturers, either for M1 passenger vehicles or heavy-duty vehicles, and each one has an interpretation of the protocol, let's say, a bit differently. So this is why it is really important to try all the solutions with different types of chargers. Yeah. This is the software tools that we have at IDIADA, and these are the test facilities that we have in order to validate the pantograph charging solutions. Yeah. Finally, this is the types of validation that we do. Many different OEMs with different charger manufacturers, and all of them have presented some issues that avoid the charge at many points. So thank you very much. I know it has been very fast, but if you have doubts, please let me know.
Great. Thank you so much, Guillaume. Thank you so much, Edwin, and thank you so much, Gerald, for your insightful presentation. Indeed, I believe our participants are so much into this now. A lot of this perhaps is technical, but then picking a few points is that it's important that charging infrastructure is planned with the future scenarios in mind. It's also important that we keep the designs simple and also making it as possible interoperable as we could, because we know that our users, even now and in the future, most of them will not be technical people. Therefore, it's important for OEMs, it's important for the sector stakeholders to keep charging infrastructure as simple as possible. And then one key point also for our local, our stakeholders in Africa is that it's important to work together as a team. So if we have a city where there are several private sector players in the field, then it's important that we work together so that we have seamless service provided to our users. And then making payment method also very convenient as possible. Then in that way, we will avoid fragmentation in the market and then facilitate scale up. Thank you so much once again to our presenters. Now we'll move on to the question and answer session. We have seen several questions coming up, and at this point, I will give the floor to my colleagues, Emily and Judith, to facilitate this process. Emily, Judith, over to you. Our first question.
Thank you, Edmund, and really good to see all the participation, the questions, the chat area is very busy, and it seems the presentations have been quite engaging. I will take the first question, and this question is to Guillaume. Guillaume, people would like to know what type of charger would be more suitable for countries that do not have a stable power supply, that is, countries that experience frequent power outages in the grid. And the second question is, what would be the minimum power output required from a charging point, and what does this translate to if using solar power?
Thank you for the questions. I might also call for support from my colleagues to provide the deeper answer to it. But in general terms, I would say the charger itself is not related to how stable the power supply is. So those are two unrelated matters. It, it, I don't think that choosing one or another would help solving the instability problem per se. That for the first question. I'm sorry, the second one was?
The second question was, what would be the minimum power output required from a charging point? And what does this translate to if using solar power, for example?
Okay. That is very dependent on the vehicle. The first slides were actually devoted to it. Light electric vehicles can be charged. So it does also depend on the type of charging. That's actually a point that maybe we should have explained a bit more. We're hearing a lot about fast charging, super fast charging. What this means is that the power is raised a lot. That is not the way vehicles should be always charged, and that I think is something that Europe and maybe North America are going for, making sure that vehicles are always charged in record time. That is actually damaging for the batteries. That links with the point in which I said the infrastructure should take into account the lifetime of the batteries. That means having a combined charging model with fast charge and what we now call slow charging, but it's actually normal charging. So for normal charging, it's again very dependent on the vehicles. So light electric vehicles can be charged, yes, with maybe 2 kilowatt charger for light electric vehicle. That would make it again depending of whether we're talking about a scooter or a electric small four-wheeler, but that would take range from 4 to maybe 12 hours. That's very rough numbers. And then as we raise, power does already raise, but yeah, it's very dependent. There's not one exact value. So for solar power, I would advise only use it for light electric vehicles. The efficiencies are not as high in charging to think that we can maybe charge electric buses for day-to-day operation with solar power only.
Yeah, maybe I can add some things regarding the. Yeah, can you hear me? Sorry.
Perfectly.
Okay. Regarding the first question, which charger or infrastructure to install, I would say that if the regulation that I was mentioning, the IC 61851, especially the dash 23, if the chargers have passed this regulation that is now currently under revision but will be launched next year, if they have passed this regulation, they will be prepared against blackout and many other type of let's say faults. So it is really recommended for you to check this, and if the charger has passed this regulation, it will operate safely and correctly in any condition. This is the type of test that we carry out here at IDIADA, and I know there are other organizations that can certificate this regulation. So I really recommend you to check this when you, let's say, select a charger manufacturer. And for the other question, yeah, it is true that it really depends on the application. So if you want to have just one charger that works for many different solutions, then I would go for, let's say, higher powers. Especially the new typologies of chargers that allow you to go to 1000 volts. So the trends would say, I would say that I would install, let's say, a 50 kilowatt charger at least, And this will work with light electric vehicles that are prepared for charging with Type 2 charger, and also M1 and heavy-duty vehicles if at 50 kilowatt power.
Thank you. Over to you, Emily.
Thanks a lot, Judith. It's great to see all these questions coming in, clearly showing that there is a need for this exchange, and it's great to see the start of this. I have two questions for Edwin. I think they are quite interesting. The first one is from the audience is, we mostly see dedicated charging points in e-mobility pilots in African cities so far. Is it possible to have dedicated charging stations for a specific fleet? So for instance, taxi, for public transport, or should they all be interoperable?
Yes, hi, Emily. Thank you for the question. Yes, of course, dedicated charging infrastructure is important for buses and for taxis and dedicated fleets, because you do want to avoid that your taxi driver has to wait for somebody else to charge his taxi or his bus. What you can do, and that is what we also see in some solutions in Europe, that you have one part of the charging infrastructure dedicated to your own taxi drivers or your bus drivers. And if you have enough power on that location, and sometimes, and in a lot of cases, it is a location where also other public is coming, and you also have shared electric charging stations, and they need to be interoperable. So if you have a solution on a very interesting location where you see, okay, it's in the middle of the city, or see a lot of public coming there, please make that a combination of dedicated charging infrastructure for your own fleet, and make it more commercial for also others. And that part needs to be interoperable.
Thanks a lot, Edwin. That's a very interesting point. I come to the second question that comes from Janvier Twagiri Mana from the Ministry of Infrastructure in Rwanda. Very happy to see you in the training. So electric vehicles are at infant stage in many African countries. Is it really a good idea to set standards of charging infrastructure now, or is it wise to wait for how many years to have the EV industry maturing and then set standards? What is your opinion?
Was about do we have to wait now for standardization, or do we have to start? I would advise to start, because you saw already in the presentation part of GM that there are a sort of 4 standards in total in the world on the connectors, so on the plugs. So that's important. And if you look at the protocols, also see that there are 2 or 3 international standards as a protocol for the user to use. So if you do not start now, it can be late. And the good thing in Africa at the moment is that you have to start, and you can choose whatever you want on the protocol side. So I think that part you can start and say, deciding, okay, what do we see for the most? What could be the most interesting also for the user? You can hear
Thanks
me.
a lot.
Was my connection bad, or was it okay?
Might be on my side as well. Thanks a lot, Edwin. Over to you, Judith, for the next question.
Thanks, Emily. Our next question comes from Ayodele Ayeni, who is working as an EV plugging e-mobility solutions in Rwanda. And he says, from their experience having deployed scalable multimodal charging station in Kigali, they found that there is huge work to be done in terms of public education and enlightenment. And the question is, how do we harness all the efforts of relevant stakeholders to ultimately ease the fear by the public in the transition to e-mobility? And it's not directed to anyone, so any of you can answer this.
Of course, it's an important question. Public education and alignment. How do we harness all the efforts of relevant stakeholders? Yeah, I think it needs to have time. Also, you saw that in Europe, for example, in 2013, 2014, it was only the pioneers who were in all kinds of pilots, and because afraid of electric mobility. And we did a lot of, and that helps a lot if you are open with your pilot and you give people also the opportunity to drive with vehicles, to see that it is fun to drive in an electric vehicle. And then in the phase after that, in Europe, a lot of regions also provided not only for a drive for one day, but also say, okay, share some vehicles and you can use it for 2 weeks. Then you can also have your freight a little bit less. And then it has to grow in the region. And if you have more and more positive customers and ambassadors within your region, then you see that it starts growing. So it is about starting to try to have your pilot open, to give people possibility to use it, not only for a day, but for a longer time. And then convince them that it is very nice and very easy to do it. And that the things that are in Europe always, the thing is, of course, am I able to charge? Yeah, you need charging infrastructure available in your region. That's important. And the other thing is always about range of the vehicle. And you see that range anxiety is everywhere, but the technology is growing and growing. And I'm sure that if you start with your pilots, if you start with the right batteries, then also range anxiety will go lower and lower. So that's, I think, part of the thing, how you do it.
Thank you, Edwin. Emily, would you like to take the next one? I see we still have 3 minutes.
Sure. I think we have a further very interesting question from Françoise Irikana from the city of Kigali. The question is, can charging stations be placed at the same place as existing petrol stations? I think that the IDIADA team, Gerard and Guillaume, you might be the best place to answer this question.
Thank you, Emily. I don't know if my colleagues want to jump on with this answer, otherwise I would.
Yeah, well, I will complement if necessary.
Okay. I would say that, and Edwin is also quite an expert on charging infrastructure location, but it really doesn't affect, so there's no technical incompatibility to it. The location should be more according to the use it's going to be made of. So typically charging stations tend to be in quite, petrol stations tend to be in already quite strategic locations that would probably also be suitable for electric charge points. What needs to be taken into account is that the power should be brought to there. So probably if we want to go for fast charging, for example, typical in highways, higher voltage should be brought to there. So it should be power availability taken into account. Then also making sure that there's somewhere populated or transited enough so it can be used. And within range, so taking into account where the location of the other charge points is. Density, population density, of course, as well, and whether the area is typically residential, with houses that can have their own charging infrastructure or not. That would also help determining the number of public charge points available. But going back to the petrol stations, typically they're located in intersections or highly densely used road infrastructure. So typically they would make for a good location. But I'm sure that would like to complement maybe.
Yeah, exactly.
Yeah.
Oh, sorry. One comment. Yes, Guillem was completely right. It is a place that is used commonly for installing charging infrastructure, but there has to be a minimum distance kept for the installation. So yes, it's been seen many times in Europe, either in America, that they use the same petrol stations for installing charger infrastructure.
Yeah, exactly. Also, what I wanted to say. You see, Shell, for example, have now also chargers on their petrol stations, and I think the distance between them is not so much. You see it on the other side of the building. So they have a service building. On one side, they have the petrol stations. On the other side, they have the charging infrastructure. So it is very good to organize.
If I may follow up just on this, regarding safety, is there something specific to observe when installing charging points at fuel stations? I'm asking this because I know it's something that we have been asked several times already on the ground.
Yeah. In terms of yeah, this is why there is this minimum distance kept in case there is any type of arc or sparks. So it is the same distance or a little bit more than the allowed one to smoke, for example. So yes, and in terms of these situations, in case there is this is why there is the charging process and many checks until the yeah, let's say the power transfer is allowed. So in case any type of hazardous situation happens, it will be contained within the charger or vehicle. But yeah, summarizing, there has to be maintain a minimum distance, and with this should be more than enough.
Just to complement the charging sequence that has been explained previously, does already make sure that no malfunction would happen. So that's why there are several safety checks before initiating actually charge, and even before the finalization of the charge. So again, if it's standardized and it has been tested for interoperability with the vehicles, there should not be any major concern. No greater than smoking. I think that the example was very, very good indeed.
Thanks a lot, both of you. That's very enlightening. I think that we can still take a few more questions. Over to you, Judith.
Thanks, Emily. It seems my favorite participant today is Ayodele, because I see another question that we haven't answered. So I read, some of the questions we have been asked by the public as we have deployed our pilot multimodal charging station is in terms of how do we manage EVs coming from different parts of the world, but with different charging points. As Rwanda, like other African countries, currently we don't have guidelines regarding this. So the question is, how do you manage EVs coming from different parts of the world, but with different charging points?
By standardization. It's what we've one of the points that we've meant to highlight. There is a need to standardize the charging sequence, charging protocols, the charging themselves. This is why we have seen this map in which there are actually boundaries in which some countries do choose to use one kind of protocol, charger, and so on. And this is a selection that needs to be made. I would strongly recommend not having I don't know, Chalemo plus CCS2 plus CCS1 working at the same time. That would make the adoption for EVs actually very messy for the user, therefore very slow and not cost efficient at all. So the good thing is that those standards we have today are the result of a very long evolution through iteration, understanding what has worked and what hasn't, and they are evolving. So the good thing is that there's no need to start from scratch. A standard can be adopted and followed strictly. The more strictly, the more seamless the charging for the vehicle will be, and yes, fleets will be able to operate. So the short answer is by adopting one of the existing standards.
Yeah, and maybe an example to add to that, if you as a continent choose a system, so for example CCS1 or Chanimo, and for example Europe did choose for CCS1, CCS Europe, then the OEM will also provide the vehicles according to that standard. And one of the examples is Tesla, who has now the CCS included in the Model 3. So it's seamless charging in Europe also with the Teslas. And before they had their own standard. So when a continent chooses a standard, it helps the OEMs to adapt to that one.
And I see we have one last question. We still have some time. The last question from Erasto Chiswano. He says, hi, I would like to ask about the concept of battery swapping. Is it able to use this concept to reduce charging time at the station? Will this have any effect on the vehicle systems? This is Erasto from Tanzania, an electric company in Tanzania.
Okay. Hello, this is Gerard from Ideada too. I think I can answer this question. So the concept of battery swapping is a very interesting concept. It's already been implemented by some OEMs. For example, at the very early stage of electric vehicle, I think it was Renault who tried to this concept. Also, there are some Chinese OEMs that are using this battery swapping concept for reducing the charging time. The fact is, for electric vehicles, the battery swapping it's a very complex issue because the battery is a very heavy part of the vehicle. We are talking around 200-300 kilos of batteries. So this is not something that the user can do by itself. It's something that it could have to be automated by some kind of robots or infrastructure, which is something that already some Chinese OEMs are implementing. But I think for the battery swapping, it's more optimal and efficient for light vehicles, for example, for scooters or motorcycles. But I don't think it's a practical practice in terms of electrical vehicles.
Maybe a short comment. I see it feasible maybe for fleets, but in the end, if you purchase a let's say quite expensive electric vehicle, you don't want to change your battery for maybe different one with let's say you don't know the DOD levels that and the cycles that have been done with this type of battery. So I would say it can be a good solution in the future for fleets and small capacity batteries, but maybe not that much for M1 passenger vehicles.
Thank you. So I'm just looking through the chat. Emily, do you see any question that we may have skipped?
I think several of them had a similar concern. So, for instance, on different connectors and the standards. I think I would just maybe like to very briefly follow up on swapping. I don't know if it can be Edwin or Guillaume Gerard talking about it, giving maybe just a very brief overview on the standardization landscape for swapping. Because as Gerard just mentioned, for electric cars, it's more challenging, but we see several pilots on the ground in African cities with swapping as as an option, and also dedicated charging points, as we discussed before. So could you maybe give some inputs on where does the thought stand on standardizing batteries? Is it fine to have different systems? As we said, that it's also possible to have a dedicated charging point, for instance.
Yeah, Emily, I'm not so aware of the whole swapping system. I know that on the passenger car side, you had better plays in the past, in 2010, 2011. And there the problem was that exactly what Gerard already explained, batteries are the most expensive part of the whole vehicle. And in passenger cars, they were. So people who wanted to have their car included a battery, they didn't want to swap that battery due to the fact that it is the most expensive part of your car. Second thing was that the cars itself, if you also look now at the batteries within a passenger car, they're not the same. They are all different. So there is no standard on the battery side. All the brands, all the OEMs, more and more they put it now in the ground floor of the vehicle, but not all of them does that. And if you have your battery, it's the whole lower part of your vehicle. It's not very easy to swap it. So I think to see that more and more the vehicles use the battery below the vehicle, so it's very low in the vehicle. It's in the bodemplaat. What is it? In the ground of the vehicle. But even then, it's difficult to do swapping. So I do not expect on the passenger vehicles a lot of swapping initiatives coming around. But of course, what Gerard said on scooters and on smaller vehicles, it is a very good chance.
Thank you. I see Vittorio with his hand raised, and I believe pretty soon we are moving on to his very interesting presentation on the future.
If you want a point of view, first of all, good morning to everybody. My name is Vittorio Ravello. I'm working for the research center of Stellantis, so a car maker company. About the swapping standardization, that was the question. For what I know, there are not activity for standardize the infrastructure, so all the place where the swap has to take place, but at the same time, maker of small vehicle like motorbikes, Yamaha, Honda, Piaggio, and others are working together to standardize the dimension, voltage, weight, and capacity of the battery to implement swapping for this type of vehicle, where the dimension and the voltage of the battery make it also easier. As said before, smaller is the vehicle, lighter, simpler is the procedure. For cars, before has been mentioned the example of Better Place, well known for Renault, Nissan, and Tesla. The big issue at the time was that if you swap a battery installed in the ground floor, the lower level of the vehicle, in the chassis of the vehicle, there are some mechanical stiffness of the vehicle, micro movement, that make under 100 more operation the reliability of the system not in line with expectations. So the system was not able to guarantee 10 and more years of operation. Moreover, there are all the problems related by Edwin clearly. Standardize the battery of a big vehicle is a complex issue. About the will of the customer to have the battery out or not depends on if I have not, as end user, to pay for the battery in a model in which the battery is in charge of another player and I buy only the car without batteries, maybe if the battery is reliable, some customer can be interested because it means pay the car one half.
Thank you, Vittorio. And with that, we hand over back to Edmund.
Yes, indeed. Thank you so much, Emily. Thank you also to Judith. And thanks a lot again to all our panelists. It's been interesting. The point is that there is plurality of charging solutions, charging standards, and it's heartwarming to know that it is time now for stakeholders to take action to standardize. And then, interestingly, we don't need to start from the scratch, as Guillaume said earlier. There are a lot of standards we can look on, and then considering the future of the sector on the African continent, then we can act now to bring some harmony into the sector. Without saying much, it means that we need to consider the future and then consider how the charging infrastructure technology is moving. So what are the future trends? This is leading us to the next presentation. We will take this presentation from Vittorio, who just finished talking to us. He is from CRF. CRF is also one of the Solutions Plus partners. So Vittorio, over to you to tell us more about future trends regarding power charging infrastructure. Thank you so much. Over to you. You can present. Yep.
Thank you again. Let's see if I am able to share the slide. Are you seeing my slide and hearing my voice?
Perfectly, Vittorio.
Okay. So I will try to sum up some of the points we have covered today and giving some flavor of the future, but I feel that as the question raised up, a lot of the possible new options are already at least in mind of also a wider audience than the technical people. First point, we are looking to replace petrol station with electrical charging station. And also in terms of the way in which we are realizing the system, there are a lot of similarities. On the left, you see a typical refueling station for gasoline and diesel, and on the right, a DC fast charging station mentioned more than one time today. As you see, at the first glance, they seem very similar. So the message that probably we want to transfer to the customer is that there is no big changes. Also, the way in which the system is done, you see the cable on the right with the connector, seems not so much different from the classical solution we have in a classical car. At the same time, when I compare refueling and recharging, there are physical differences. And these physical differences are very important because from some of them comes out all the problems and the need of some way complexity that the standardization and communication is highlighted before. When I make a refuel, I simply move a fuel from a tank that is under the station in another tank that is in the car. It's like to move water from the bottle to a glass. So very simple transfer of a liquid. When I make, on the other end, electrical charging, I'm not transferring electrons in the car like maybe someone can imagine. I am making make possible chemical reaction, in particular reduction oxidation reaction. That means a complex process with efficiency, aging, safety issue, and concern around that make possible to transfer ions inside the battery because the energy is still there, simply to be recombined. When I look at the time, the big plus of the fuel is that ask for a very short refueling time. I make a refueling in a few minutes at the end of the story, and maybe we are not aware, but when we are doing that in our hands, physically speaking, we are passing megawatts, up to 10 megawatts of power flowing in our hand. Now we said that that's absolutely true, the electrical systems are more efficient, but at the same time, if I have to compare tens of megawatts with something also 1/3 of that because it's 3 times more efficient, it means megawatt power also at the electric side. And that's obviously it's not so easy. And in general, if I want to make a complete recharge, and not some simple transfer of a fuel, but a chemical reaction, the time is higher. As mentioned before, today we are not experiencing wait of time making refueling, making recharging is on the other hand something that asks time. And obviously, to make faster the charging, we want to put higher power, and higher power can draw together also problems, safety problem, and all what this system can have with that. It's very important also to take care in this evaluation of the impact that this time and the efficiency of the battery charging has. Why? Because charging times is a time in which I cannot use the vehicle. And that's something we've not in mind with standard cars, the petrol one, because as we said, refueling is very short. Here not. So if I have to leave my car 8, 9, 10 hours, I need to imagine a phase in my day and night where the car is not needed, like the night time. Also, the efficiency is important because people obviously is concerned about the cost. That's obviously very important. And when, as in mind, refueling and recharging, feel that the second one is cheaper. At the same time, when you do refueling, you pay the fuel you put in your tank. When you make charging, you pay the electricity you take from the grid. It is not the one that goes in the battery, because in the middle there is the efficiency of the charging system and the batteries. So this efficiency is also a matter of how much I pay. The way in which I connect the vehicle to the charger, here we have seen today a lot of discussion of classical conductive connection, so plug and socket, pantograph, that is anyway another form of conductive connection, is very important because it impacts on the usage experience, how much complex is this connection, as said before, how much pass the system has to do, how much automatized they can be or not. The safety, when we speak about hundreds of volts, obviously safety is a very important point. I am putting my hands on something that is 400, 800 volts. And finally, the infrastructure, I need to support it. As said before, we are pushing a lot the so-called partial DC fast charge. In few years, we have been moving from charger at 50 kilowatts from DC fast charge up to the today one that are ramping up with 800 volt to 350 kilowatts. And that is a very massive impact because car makers can run behind these trends and make new cars relatively fast. Relatively fast means some years. If I'm putting on the floor an infrastructure, this infrastructure I expect can be applicable for at least 10, 20 years. I'm not making a road, a bridge to rebuild it in a few years. And so decide if I select 50, 100, 200 more kilowatt in the case of DC fast charging, 400, 800 volt, conductive, non-conductive, CCS1, 2, all the standard, there's a large impact, undoubtedly. That's very, very important. This run that you see in the slide has behind the idea to make electric vehicle like the standard car, the today cars, the 800 million petrol engine car we have on the globe. Why? Because the logic is to make the charge shorter and shorter. At the same time, this means, and that's the reason why I increase power, because I want to put in the vehicle a certain amount of energy that is the product of this power by the time. So shorter is the time that I want, higher is the power that I need. And at least for big trucks, buses, cars, unfortunately, we want to increase. Unfortunately, we want to increase is not so correct. Unfortunately, to increase the range, as we expect, so 100 and 100 of kilometers, we need at this point more energy, and more energy without increasing time means more power. Higher is the power, higher are the also grid side issue, because here some simple example, if I stay in energy OPEX this range that are typical for mid-size and big-size cars, and I want to go down to this charging time, at least for the DC partial charge, that is 80% of the total, it means to range between 200 kilowatt roughly up to more than 1 megawatt. And also, if you want to make a station wherever you want, imagine on an highway, clearly the question is not only if I can put it closer or not to the gasoline existing, but the question is it possible to move there these power levels? Because if I want to charge in parallel multiple cars, you have to multiply this figure by 10, 20, how many slots, how many charging slots you want to have. And that's clearly very impacting. Another way that electricity allows is to start from another starting point. The two elements are the following. While to make refueling, I need to go to a refueling station. To make charging, I can do charging potentially in multiple places. I can do, if I have at home a garage, for instance, or a parking slot, at work, if I have an office with some parking slot under the office, in public area, devoted area, supermarket area, movies, big places area, like growing up, or in the future, or coming up highway charging station similar to the fuel station we have. Having this plurality, I have multiple choice and multiple opportunities to do charging. The point is that I have to integrate the charging in my scheduling of the usage of the car. And for vehicle used in town for a limited number of hours in respect of the 24, meaning a lot of time parked, this opens the door to a lot of opportunity. The simplest is to charge, if I can, the vehicle at low power at home during the night, if I don't need the vehicle in the night. But it can be also during the daytime at work, or making my shops activities during the day, in the late afternoon, or in the weekend. So I need to rethink the process, use this fast charging when needed. Obviously, if I speak about buses, it's a matter of needed, but for cars, a smaller vehicle, maybe not. So I have to open the process to try to minimize the power level to the one I really need, case by case. Other opportunity coming together with this is that I can imagine with, in the case of AC charging, a bidirectional charger on board, in the DC case, simply using the DC station, to make the vehicle interact bidirectionally with the grid. Today, we are used to imagine the vehicle, electrically speaking, as a load. Electricity moves from the grid and goes to the vehicle. In this model, I can imagine that sometimes the vehicle is a storage supporting the grid. Here in the picture, you see the support of the full grid, what is called vehicle to grid, that asks for the, let me say, combination of multiple vehicles in different places or in the same place by all the operators that Edwin very clearly explained are between the end user and the energy producer. There are a lot of players here you see in the middle. But these can also be played on a lower level locally at home, in the so-called vehicle to home. Imagine to have a place with a PV roof. I can use the vehicle when parked and the roof to better balance the usage of my electricity at home and minimize the exchange, particularly the inlet exchange by the grids in the daytime, where the grids can give me the electricity at a cheaper price. And so the vehicle can become from a simple and different element of the play of the mobility in respect of the energy grid management, a toy, an element, a player of the integrated system. The revolution we have in front of us is putting the two words, the energy production and management and distribution and transmission on the right side and the mobility on the left in a clear conjunction. And that was not possible with oil. So it opened a totally different way to imagine this share, and it is still to be understood. There are a lot of demo projects, research projects also. Recently, there are some tenders coming from European Commission, for instance, but it's a word to be understood, because in the game, all the time I discharge the battery for this second service, I am cutting kilometer of usage of the vehicle. So I have to tailorize the usage and the life of my battery depending on the real needs. If I take a car with a battery giving me 200,000 kilometers of life, for instance, but I use in my life only 1/2 of them because I don't need this range in my life, I can devote this part of the energy, for instance, for the grid. Maybe also more, because the way in which I discharge is less impacting on the life than the one I do using the car in the classical proportion. Going to the end. Other option I can take in the pocket. One has been already shown, particularly for big trucks, big buses, can be this one. So a conductive system on the upper side of the story, like it is a trolley bus today. In this case, this comes from the fact that the average power of big trucks is in the range of 10 to 100 and more kilowatt. And so clearly, a battery is not the easiest way to manage these long range vehicles. Good point of that, infrastructure is largely validated, is like a tramway system, not indifferent, is not sacrificing this line only for the vehicle. I can use the line for classical vehicle with batteries or other sources without the connection. Clearly has an impact on the environment, and someone does not like clearly the impact of this infrastructure on the landscape. Another way, but is more long-term research, is to use a wireless system, so no conducting, no contact, but through the air, using the electricity coming from the ground, what is called wireless dynamic charging. Here we stay at the level of demo project. Here you see an example coming from a Renault vehicle in a plant realized with Qualcomm in France, close to Paris. Here research coming from American institutes. Here the logic is to create, for instance, a lane where the electric vehicle can charge going at a slower speed, when charged go back in the full lane and go at full speed. So this plurality of system can open the door when and if available to a more, let me say, complex ecosystem to solve the mobility issue. Before was mentioned the battery swap. Battery swap, as I already said, I do not repeat what I already said, has some good points and some limits. Clearly, for smaller vehicle can become very relevant and very interesting. And the small vehicle, what goes under the field of mobility as a service vehicle typology, can be a bridge between vehicles today very different from classical cars, like a scooter, like three-wheeler, light four-wheeler, and smaller cars, M1 or less, sub a segment that become vehicle fitting this mobility in which I do not buy the car, but I usually leave the car. In this case, going at lower voltage, lower power, at lower volume, this swapping can take place, and this battery can be, if correctly standardized, be shared between a scooter, a motorbike, and in a multiple number, also a car. Last but not least, I don't want to open the door too much to the point because for some extent seems a different technology, but a very relevant opportunity can come also using in a wise way hydrogen. Hydrogen as electricity is a vector, an energy vector, and can sometimes cover some needs of higher range. Here is an example coming from Stellantis of a commercial vehicle in which, thanks to the hydrogen on board, the refueling, because here I put hydrogen in the vehicle instead to put electricity in the battery, asks for 3 minutes. I don't want to say that it is the solution, can be a solution. This is an electric vehicle, by the way. Maybe not all the people are aware of. The vehicle has anyway an electric motor, an inverter, some batteries anyway to manage the charging and to balance the fuel cell. Is a zero CO2 well-to-tank car, tank-to-wheel car, sorry. And so this can play a complementary role. Last point on my side, and then I will shut up myself. Before someone was asking how to manage charging in place where there are a lot of outage of the grid. A good way is to integrate the charge in place where there is the charger that obviously, as correctly said, is independent. It is a device transferring electricity, so it's not able to avoid an outage effect. But if you integrate the station with PV, with solar PV, a roof of photovoltaic systems, batteries, stationary batteries in place, and if needed, also fuel cell systems, stationary in this case, you can have a charging station clearly more complex, clearly more challenging, but able to supply electricity to the vehicle, or hydrogen in this case, also when the grid is not in service for any outage reason. So the goal passes through this full integration of the different opportunities. And that's from me, so thank you for your passion and attention.
Thank you so much, Vittorio, for your presentation. It's amazing to see how we have so many future options. We would like to take the case study from Gerald, then we will wrap up. So Gerald from Idieda, over to you to give us the case study on electrical safety.
Okay, hello. Let me show my presentation. Oh, I don't know if you can see the screen now.
Not yet.
It's not yet, William. Shall you can try again?
Okay. Now?
Yeah.
Yes.
Yes.
Good.
Okay. Hello. I present myself. I am Gerard Ibars. I work in IDIADA with Guillem and Santi. I'm in the powertrain electric team, so I'm responsible for electrical safety test and also some durability and testing for high voltage components for electrical vehicles. All the power electronic components integrated in a vehicle are tested in my department, and I'm responsible of part of the test. So I will try to go as quick as possible because I know we're a bit out of a schedule. But I will resume my presentation in two main parts regarding electrical safety and functional safety. Both are related of the electrical vehicle. So my point is to show how the electrical vehicle is a safe vehicle, because there is a lot of doubts and a lot of misunderstanding on how this kind of vehicles work and how they can be safe, because there is a lot of years of combustion engine, and I assume it was the same at the beginning of the combustion engines, that people were afraid and had risks of fires and what should be done in case of an accident. So we are in the same spot now with the electrical vehicle. No, people is concerned about having fires, having electrical shocks, and there is another element that electricity cannot be easily seen. So this adds another element of risk and of fear to people. But overall, we have to think that the electricity has been all around us since a lot of time. So it's a very proven technology, and all the experience of other fields of electricity are applied now to electrical vehicle, converting it to a very safe vehicle if all the conditions are met correctly. I will start with a little briefing of how the regulations of electrical vehicles are done today. So let's start with the Global Technical Regulation number 20. This is a regulation that it's international, so it's not only for a determined country or continent. It's a document that it's global, and most of the electrical vehicle regulations are based on this document. This document is for free, and you can check it online, and you will see that there is explanation of all the main safety topics regarding electrical safety. I will specify the European regulation regarding electrical safety. This is the regulation of homologation of of all vehicles, which include the electrical vehicles, and the two main regulations regarding electrical safety on vehicles. That's R100 and EFMB SS 305, which is the American one, North American one, which are exactly the same document. And all of these documents are based, as I said, in the GTR number 20. There is some specific points that they are mentioned in the regulations, but I will not go into detail because this is quite just an overview of the regulations. There is this regulation, which is a new regulation regarding electrical scooters, and there is some other characteristics regarding a little bit less voltage and some requirements of speed. And then there is this regulation which is applied to electrical motorbikes. But in this case, there is some peculiar things that, for example, in Europe, this regulation is not mandatory. With this leads to some strange situation, because this regulation is the mother of two other regulations that these are for electrical bikes and cycles. No, so this leads to a situation, for example, in Europe, that electrical cycles, we could say they are safer than electrical bikes, because for cycles it's mandatory to compile this regulation, but for bikes and from determined voltage is not mandatory. This will change in some years from now, but this is just a curiosity to know. There is also this regulation which is aimed to some ambient and physical test to determine whether a component is safe for touch and for water, which is another of the big concerns of electrical vehicles, if they are safe enough in situations of water, no? Which is the IPX4 protection. So, in order to synthesize a little bit this part, we can define three main parts of electrical safety, which is the protection against indirect contact, is the protection against all the electrical risks that cannot be seen. For example, the electrical shock risk of touching any metal parts that could lead you to some danger. Then there is the protection against the direct contact, which means the car shall be physically protected from this electrical risk. No, for example, if there is a lid, a plastic lid, then it will prevent me from touching any electrical hazardous part. No, and then there is the functional safety, which is a little bit more complex, which is regarding the control and safety of the electronics of the electric vehicles, because at the end these vehicles are very complex in all the control and all the process that controls the car. So it's important to have some safety elements there. Just a few briefing of the points that shall be checked during protection against indirect contact, which are, for example, that all the metal parts shall have a low resistance in order to avoid any interferences in the control of the system, and also if there is any leakage of electricity, that can be the metal parts of the vehicle can act as a ground in order to have some safety. There is also the insulation resistance of all the high voltage parts and cables. That should be a high value in order to prevent any of the electricity leakage, and then preventing people from getting hot. And also that all the connectors and all the electrical parts shall be insulated, so there shall be no contact during the metal parts that are not supposed to be electrical and the parts that shall be electrical. No? And also, which is a little bit obvious, that all the cables and all the electric parts shall not be with sharp edges, or also they shall be protected against overcurrents and all these, I would say, passive elements to prevent any damage of electricity. And we have to the direct contact protection, which is IPX4 protection, which this is mean protection against water. So all the electrical vehicle components shall be protected against water. So does it mean that if there is rain, there is a flood, or there is any type of water exposure to the vehicle, that the vehicle will not have or will not present any problem? No? Then there is the IPXXD protection, which means that all the metallic parts of the car are not connected to high voltage parts. So this means that, for example, in the cockpit, you cannot touch anything that will give you an electric shock. And also something that we mentioned before, that the cables shall be in good shape, and they will not have any risk of getting cut or getting exposure of the cable, in order to be safe for the user. Then I will switch to the functional safety part, which is a little bit more complex. So I will start a short briefing of how a vehicle is developed. Okay, so if we start at the beginning, there is some requirements or some key points of designing a vehicle. Then we start defining some of the parts that we want to be implemented. For, let's put an example of the steering wheel. So we want the vehicle to have a blocked steering wheel if the car is parked. No. Then we will think about which are the elements that we need to, in order to do this action. No? So we shall decide, okay, we need some kind of motor and some kind of brake in order to prevent the steering wheel to move if the car is stopped. And then we would start programming all these functions in order to achieve this control. No? At the end, we would implement some software, and then we will try to test all these functions. No, we would try this only in simulations in the computer. Then we would simulate with the ECU of the vehicle, and then we will switch to try this system with the ECU of the vehicle and the steering wheel of the vehicle. And then we'll do some tests with all the components, and at the end we will try all these parts in the vehicle with the whole vehicle. All these arrows means that in each step we shall try and develop all these functions, and if something is wrong, we shall then go back to the equivalent point in the designing. You know? This development of the vehicle is important in terms of functional safety, because functional safety is the study of all these functions and how can all these functions be safe in the electrical vehicle. No? At the end, we can just resume this, that all the actions that we can do in the system in order to have the vehicle safe. No? So at the end, all the elements of functional safety can be very complex. We can go to a very deep of safety, no, in order to have all the program lines of the code to be double checked and to be safe. But at the end, it's just an overall thinking of all the functions of the vehicle and all the parts of the vehicle that shall be protected and be safe. Just a few resume of the expertise that we have in IDIADA regarding all these topics. So, for example, in order to prevent that all the to ensure that all the components are safe, it's usually done some test to the component itself. There is some parameter test that in order to show that the component is working properly, and then there is some environmental test that we have expertise in here. Just some experience that we have is that, for example, we've tried some charger or some components, and the changes of temperatures, and for example, during the cycles of day and night, could lead to some short circuits in components. So it's important to try all these components when designing a vehicle and when the vehicle is out, to ensure that the durability and all the safety elements are met, not only theoretical, but in a practical way. So this is just a short list of main tests that components of electrical vehicles are exposed to in order to ensure that the vehicle is safe in all aspects regarding the control and physical. So thank you all. And if there is any questions, I will be glad to respond.
Thank you very much, Gerard, for your presentation. We've run a little over the time. Do we have any pressing questions now? Otherwise, we can continue the discussion in tomorrow's session, where we will be discussing financing charging infrastructure. Emily and Judith, do we have any questions now, or we wrap it up now?
Thanks, Edmund. I think I see the only question was by Ayeni, which we will push to tomorrow's Q&A. So we welcome all participants to join us again tomorrow and we can take any unanswered questions either sent on email or in the chat in tomorrow's Q&A.
Great. Thanks a lot, Judith. So we would like to invite you again to tomorrow's section, where we will be discussing financing, public procurement, and then business models relating to charging infrastructure development. We are happy you joined today, and we hope that you join us again tomorrow. It will be great to have this as a sequel. It's a complete set of training for you. So we will be happy you join again tomorrow, where we will deliberate on the economics side of things. So thank you, all of you. Thanks so much to all our panel members, Emily, Judith, and all participants who joined us today. See you tomorrow for another wonderful session. Bye-bye.
Thank you a lot. Bye-bye.
Thank you.
Thank you.
Thank you. Bye bye.
Thank you. Bye-bye.